Alright, so next part is where you'll be given the probability where you know the binomial and everything, but you do not know the number of x this time. We know the probability, but we do not know the number of x. Okay, what do you mean by that, sir? Alright, let's try this problem, such as you're given something like this. Oopsie, well, it's still okay. Where it's a binomial where the n is the n is 10 and the p is 0.5. And you were told that where px more equals to a is 0.4956. So in other words, you know this value over here that you want to find, but you do not know the number of here which one you want to know. Okay? So it's a reverse osmosis process. I used to say that. Because when I learned about this, my parents just bought me the water RO, reverse osmosis. At that time, it was the in thing. Okay? So 0.45, so let's find the book first. Where is 0.45? Hey, that's 0.45. The n is 10. Hey, we got the correct page on our first guess. So the n is 10, p 0.45, and I know it's 0.4956. Alright, so more n equals to a, so that means we're already moving in the left to right direction, okay? Did I find it here? Oh yeah, I find it here. 0.45 and it's 10, and I look on this table, this here, and I can find 0.4956. So that means my A is 5. Okay, this is the reverse process. It's not that difficult. You just need to be a little bit calm. So from the table, A is equals to 5. Okay, so let's try another example. This one you need to be a bit careful. Let's say for this time you're given something like this, px less than a, 0.89801. Okay. I need you to understand a few things. Okay, if we do the room technique for this case, so it's going to start with 0, 1, 2, but we do not know where is A. So we write down A over here. Let's say it's a proper A, not 9. What's the one number before A? We do not know right now, but it's going to be one number less. Do you agree with me? So it's going to be A minus 1. Can we agree on that part? What about one number after A? A plus 1. And we know the n is 10. So it's going to be something like this. Before one number of A minus 1, one number after is A plus 1. So you want less than A. So how much is that? Which direction? Less than A, that means? Alright? That one gives me 0.89801. But I know our tables is reading from left to right. So how do we should do this case? 1 minus. So that means, sorry. Less than A, does A included? Not included, so it's only until here. Alright, so So it's supposed to be Px more and equals to A. Sorry about it. I need to write down properly. Less than A, so that means Px less and equals to A minus 1. We know this one for sure. And we want to find this direction. So it's supposed to be 1 minus Px more and equals to A. Alright, that's more like it. This can be dangerous. There are many ways to look at this case right now. I think that the most unconfusing way, the notes here is a bit confusing. Let me redraw it a bit. The notes doesn't work with my brain. So let's say this is A, the one number before that is A minus 1. So I like to view this one as 0.89801, where this one is Px less than or equals to A minus 1. Can you agree with me? So this one will be what? 1 minus that will be 0.10199. This one is for Px, which direction? More and equals to A. Okay, this is the least confusing. I can do it. So can we find it in the book? This is confusing, so that's better. It's not really there, but which one is our nearest? Okay, 0.1020. This is our nearest, so 7. So A is 7. Are you okay? I like this way more than calculating over here. Right? Okay, now the toughest one. Let's say you're given something like this, Px equals to A, 0.23836, and now I want to find the value of A. Okay, now you need to understand, this one is equal. It's not less, it's not more. So normally if I go with equal, I say if I want to find the probability, formula is the best. But it doesn't work this way. Because we know this one, we want to find the x. Okay, so let's go back to our room. So A minus 1, A plus 1. Equals to A. Alright, remember, the table reads from left to right. So, you want to find specifically this one, okay? Specifically this one, okay? Let's say there's good A. So, how we calculate is all of this minus all of this. Understand? Then we got the A. So the blue part will be Px more and equals to A minus Px more n equals to a plus 1. Are you following me? Good. And we know this result is going to be 0.23836. Okay, but how the heck are we going to find it from the book? The best way to do is to find the two values, you need to minus them up. So let's say if I minus from the 10 and from the 0 and 1, if I minus it out, I'm going to get myself 0.0025. 1 minus 0.9975. I get, okay, 0.0025. Is it somewhere near to this one here? No. So I need to make a good estimation where it is. So if I minus these two things, I want here to get 0.2. 0.9 minus 0.9. And I go further between 3 and 4. 0.9004 minus 0.7340. Oh, this one looks quite promising. One 0.1664. No. This is not what we're trying to find. And we go further down. 4 and 5. 7340 minus 0.4956. 0.2384. Ah, looks near. Oh my, that's very near. So it's between 4 and 5. Okay, wait. That's one thing. Let's try another one. There's one more down here. 0.4956, just to be sure, minus 0.2616. 234. Just now, what did we get? 238. 238 is better. So our A is, we got, just now we got, we minus between what and what? 4 and 5, right? So this one, A is 4, 4 plus 1, 5. So A is 5. Got it? So from the table, A equals to 4. Right? Got it? Congratulations if you've made it that far. Okay, that's all from me.